It's my pleasure to extend a cheerful welcome to you all to this free online summer course on evolution and advances in electronics and communication technology. Welcome the challenges. Look for the opportunities in every situation to learn and grow in wisdom. Brain Tracy says these words. I now extend a warm welcome to our resource person for this evening, Dr. Benjamin Joseph, on behalf of our respected college chairman, Sri D. Duraisamy, vice chairman, Sri D. Parandaman, secretary, Sri D. Dasrathan, joint secretary, Sri S. Gopinath, correspondent, Sri S. Amarnath, director, Sri D. Sabarinath, our beloved principal, Dr. S. Ramachandran, head of all UG and PG departments, professors, faculty members, and students of our institution. Thank you, Dr. Benjamin Joseph, for joining with us today. Before we begin this event, let me share a brief introduction of our institution. Dharma Naidu Educational and Charitable Trust established ECE Engineering College in the year 1998 to 1999. We are a NAC A grade and ISO 9001 2015 certified institution located at Tirverkadu. All our departments are NBA aggregate. We are working autonomous from 2019 for a span of 10 years. We have 24 years of excellence with 9 UG programs which include BE, ECE, EEE, CSE, Civil, Mechanical and BTech, IT, Artificial Intelligence and Data Science, Computer Science and Business System along with 6 PG programs which are ME, CAD, CAM, CSE, Communication System and Embedded Systems Technology, MBA and MCA. We also support various doctorate programs in CSE, ECE, EEE, Mathematics and Mechanical Engineering. SA Engineering College stands out in the crowd for its Anna University recognized research centers with 27 funded projects where students get chance to work on these projects. We provide highly comprehensive placement of about 90% each and every year. We have achieved 90% of placements even during this pandemic in the year 2020 to 2021. Our top recruiters include Avasoft, Rapid Data, Emphasis, Infosys, Capgemini, CTS, TCS, Zoho, L&T. We have introduced latest courses on artificial intelligence and data science, CSE and business systems. We have a state-of-art infrastructure including Internet of Things Lab, Product Design and Development Lab to conduct research projects. SE Engineering College maintains high standard of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members, and creating an ambience of conducive quality education. I now request our resource person, Dr. Benjamin Joseph, to take over.
Yeah, fine. Yeah. Good evening to one and all. Am I audible over here?
Sir, you are audible, sir.
Yeah, fine. Now, thank you for the wonderful welcome and introduction, Ishrat and Kavipriya. And let us now start with the session and presentation. Now, let me share the details. A very wonderful evening to one and all. Now I'm sharing a presentation of me. The title of the presentation is Evolution and Advances in electronics and communication technology. Now, in today's era, this electronics and communication plays a vital role in day-to-day life from the start to the end. Each and every part of our life is governed by this electronics and communication. And I want to start this presentation with a quote that if you can't fly, then run, please. If you can't run, then walk. If you can't walk, then crawl. But whatever you do, you have to keep moving forward. My dear audience and my dear students, those who are present over here, I hope so this presentation will be an eye-opening session to everyone, those who are participating over here. So keep moving on your life. Don't get stopped over at any moment of your life. I'll take this presentation in an interesting manner, as well as you will be gaining a lot of information and not the data, because the data is a repeated information and that I don't want to do it. I want to give you an information. And if any queries, please ask me in between. Now, this series, the tech series, is divided into two sessions, day 1 as well as day 2. Day 1, we are going to talk only about the electronics that advances, and day 2, communication, and specifically we'll be talking in the perspective of Internet of Things. So anything which we do, we have to plan. Failing to plan is planning to fail. I have planned a lot for this session to make this session very innovative and interesting. Now, then I'll come into what to say is I'll change this session into an interactive section. First, I'll say that what we are going to do with, that is, first we are going to see what is the objective of this program, Introduction to Engineering. Many say we are engineers and engineering, and we don't know what is the exact meaning and where it comes from. And what are the various engineering branches, evolution of an engineering from the ancient days, what is the exact meaning of an electronics, and evolution of the basic laws. Without the basic laws, there is nothing we can't do with the electronics. Evolution of the computing devices, the processes, and what are the prerequisites for the engineering. Hey, maths is fun, and most of us are afraid of maths. Today, I'm going to show you how the maths is very easy for you. And next is, what are the active and passive components available in electronics? And then we are going to move into the sensors, which is a very vital part of an, what to say, is an IoT. Then evolution of an electronic devices, evolution of processor. At last, I'm going to conclude everything is electronics. So before moving into the vital part, that is once again going into the topic, let me have a session with you. What the thing is, could you able to understand the speech which I'm giving for you, and how many of you are present? You can put an S in the chat box if I am audible. If I'm audible, you can put an S in the box. And also I'm sharing my screen, and then once it says, I can move on with the rest of the details. It's all right? Yeah, everyone can see and hear. Okay, fine. Audible and understandable, sir. Yeah, fine. And I hope so you can ask others also to join us up. Okay, fine, thank you. Now, the main important thing which we are going to see over here is, once again, when we are making it up, the objective. Why I'm going to learn these things? What are the things I'm going to learn from this course? First, you're going to understand the basics of engineering and engineering branches to make aware of engineering evolutions. And next, you're going to understand the basics of electronics to understand the role of electronics in day-to-day life. So engineering is a magic, and it involves many concepts and many laws and also many mathematicals. And at times we say that we can do something without the mathematics. No, in any kind of an engineering. Mathematics is important. I'll come to that part. So only here Thomas have defined very clearly, engineering is the art of directing the great sources of power in nature for the use and convenience of the people, right? It is already available in nature. Everything is available in nature. I'm going to utilize it properly for the convenience or for the use of the society. So engineers are called as a profession because they have greater responsibility in the society. All right. So these are the objectives. What we are going to learn is, once again, I'll recap what is engineering, evolution of an engineering, basics of electronics, and role of electronics in day-to-day life. And next, we are going to see how this word engineer evolves. And actually, the word engineer evolves from a Latin igniter, which is derived from the Latin word ignition. What does that means? To devise, to contrive, right? To develop. You can say another word for a device, a develop. And ignium. Ignium means cleverness. So something, an engineer means to devise cleverly, to devise newly, to devise creatively, to devise innovatively. That's what we mean it to be an engineering. So what the Einstein is saying is, scientists investigate that which already is the engineers have created, but engineers create that which has never been, right? Engineers have the role that they'll be doing things which no one have done yet. That is the role of an engineer. And those audience who are listening and those students are listening, you have to be an innovative engineer and not an ideal engineer. Who is an ideal engineer? Who just learns and do what they learn. It's not like that. Practice, and you're going to, according to the word meaning, you're going to devise, you're going to develop with cleverness. Cleverness is entirely different from what you're learning and implementing. And now we'll see who is the engineer, who can be called as an engineer. Many people think that if I go with a degree and go with certain things are called as an engineer. No, never, my dear students. If you're having a creative thinking, and everyone is having a creative thinking, and mind that no one is born without a 0% intelligent. Okay, creative thinking. And next one, who is able to design, right? Not only thinking, not only an imagination. That imagination should come as a design, and that design should be implemented. It might be any branch of engineering. This definition is common to all branches of engineering. So implementation is important. And how you implement, some will be implementing technology, they will be using technology constructively, some people will be using destructively. But an engineer should do constructively, that is for the welfare and safety of the society. If I'm devising a railway system, a railway engine, or if I'm devising a bridge, if I'm devising a space device, whatever might be I'm devising, I'm inventing some things that is now the latest trend is your Internet of Things. Everything is for the safety and security of the society, the people. And once an engineer have to attain the problem, right, from the natural things, what the people are facing, what is the day-to-day problem, and that problem an engineer should try to solve it in a creative manner. Who is the first engineer? Most probably we know many scientists or all other things. So in the left-hand side of the slide, I've given Imhotep. He is the first engineer who is a civil engineer. We can call him to be a civil engineer. He's from Egypt. He was building a pyramid. So he was the first engineer who has doing these things. So this all with the introduction with an engineering. Okay. So next, when we are saying engineering branches, we have a n number of branches, but certain branches are very important, and we are called it to be the base of all the engineering. Initially, whenever in our olden days, if you called an engineer, immediately they'll say that civil engineering is an engineering people because they build homes, they build shelters, they build bridges, because that are all the basic necessity of a human being. What is the basic necessity of a human being? Shelter, food, water, and all these things. So civil engineers provides that basic needs to everyone. So those who are all want to be a civil engineer, you should be proud that you're going to be a civil engineer. You're going to give the basic needs of the people. And again, suppose if I want to travel from one part of the nation to another part of the nation, or one part of the region to another part of the region, or I want to devise a new mission or something like that, there plays a role of the mechanical engineering. Okay, so without the mechanical engineering, now we are driving the bike, we are going in car, we are having an outbuild of an airspace, aircraft, everything is depending upon the mechanical. And the world has become so bright, it is not a dark. In ancient days it was dark, now it is bright due to the electricity, that is due to the electrical engineering. So they play a main important role, turning out the dark into the light, right? So, and also they give power to every department, electrical department. And now the very base and the very important department now ruling over each and every part of the engineering is electronics and communication engineering. How I'm coming to say that? Now, when a civil engineer wants to develop a smart home with different sensors, with a different lift or different criterions, what are the automation systems? I want a camera to be fixed, and in designing I require certain simulation to be done. All these things are possible through electronics and communication department. And once, if you consider now mechanical department, if you consider all the construction, all the machinery works are done through robotics. If there is no electronics and the sensors concept, there is no robotics, and the control systems and all these things will come under the electronics and communication. So in that mechanical branch also, this electronics plays an important role. In electrical devices, in most of the power electrical devices, electronics plays an important role in that branch too. So only that branch will be called as electrical and electronics. It is not only an electrical branch. Without the aid of an electronics, and each and every department, my dear student, even though I'm from an ECE department, I want to say that each and every department are depending on each other. But electronics also depends on other departments also. But electronics now governing each and everything. For example, if you take a mobile, if you take a laptop, everywhere, whatever you're using, the youngsters are using, without an electronics, you can't do anything. And mainly, we are now running after the computer science engineering department. When you see that a computers, it has a software part as well as the hardware part. But even though there are a software part, they are the software developers, really they are essential for us. But without the transistors, without the processor design, nothing we can achieve in the computer. Without this electronic component, I can't jump into this department, that's computer science department. And without any power supply given to the computers or something like that, I can't do that. Without the framework of the mechanical engineer, we cannot develop a computer design. All right. And if I want to place the computer, I cannot place the computer in the street. I have to place the computer in some indoor developed building that is done by the civil engineers. So each and every department is very important, but my state of interest stays where? But if you consider, on my point of view, this EC department, when you're learning, because since I'm representing an EC department, if you're learning an EC department, you will be learning about what all the things you will be learning about, we'll see one by one. I'm thinking so you are now clear with the engineering branches. All right. So how they are dependent and which part is very important and which is playing a very important role in a day-to-day life. we'll see one by one. I'll move to the next slide and then I'll conduct a connection program to just make ourselves boost enough. Now, just I'll play in video for you to just see, to just infer how this electronics have started, or to say that how not the electronics, engineering has started in 16th century itself. It is not in 20th or 19th century. From the 16th century itself, the engineering is evolving. Just I'll play in video for you. Please just observe it for 3 minutes. I hope now you have made a, that is, you understood how the engineering evolution have started from the beginning. Now let's come to the panel now. I just want to, just a second, we'll just come into the thing. How many of you are here and can you able to understand the things? Are you okay with the things? Can I have it in private chat? Because whatever I'm sharing to you, whether it is visible and all of the things, just I require a feedback of that. It's okay? Shall I continue with us?
Yes, sir. You can continue.
Yeah, fine. Thank you. Now, the second thing which we are going to go over here is the meaning of an electronics. What is the real meaning of an electronics? Just I'll roll over the slides. Meaning of an electronics. Electron and ICS joined together will be called as an electronics. It refers to any discipline that is ICS. ICS means economics, mathematics, aerobics, like that. So electron plus ICS, it is a branch, it is a discipline. So only we call it to be an electronics. Okay. Now, here we are not going to control the charges, but here we are going to control the electron charges, that is negatively charged material, right? And how these electrons are behaving in the vacuum, gases, and semiconductors. Mostly we'll worry about this control of electrons in semiconductors, because most of the devices now which we are using as an electronics devices are semiconductors. Okay, so and with that devices, that is semiconductor devices, how we are going to control the flow of an electron. Generally, the material is being divided into three things. Will be dividing in the materials. Just I'll come to the board also, such that you will be having certain clarity whenever it is required. Now listen here. The first material which we had is a conducting material. It's your conductor. We call that material to be a conductor. The second material, generally we call it to be an insulator. And the last one, that is the very important one that we are using in electronics, is semiconductor. It's semiconductor. So conductor, it conducts full current, right? There is a full current, that is, if you consider a copper wire, it will be conducting the electricity. But if you consider an insulator, no conduction, we can take an example as an wood. Likewise, in semiconductor, it is a partial conductor. It is a partial conductor. And all these things are related with chemistry also. It is not only a physical term, it is a chemistry. That is the material bonding. You would have already learned about in the chemistry the covalent bonding, and there is a strong relationship between this covalent bonding and what I'm talking about, this semiconductor materials. In semiconductor materials, the energy gap level will be very less, right, than the conductor. So in case of a semiconductor, initially the used semiconductor is germanium, and then nowadays mostly used is a silicon. These two semiconductors are said to be a pure form of semiconductors. Could you able to understand? One is conductor, insulator, and semiconductor. In nowadays, in all the electronics technology, we are using the semiconductor. That is a pure form, and there are also an impure form of a semiconductor. And about this, students, if you are learning, if you want to learn about these devices and all these things, you will be learning a separate subject called as an electronic devices in the third semester of your engineering. In that case, you will be learning in detail what are the semiconductor devices. In these semiconductor devices, if you consider the basic semiconductor devices, it started with the PN diode, and second one is your bipolar junction transistor. So this how we differentiate between the materials. So here, whenever the electronics are coming into the role, right, when electronics coming into the role, the semiconductor terminology you shouldn't forget. Next, we'll move to the next part, that is with the slides. and then once again we'll come to the board work when we are working with the basic laws. Now, listen here. What is the work of this electronics, right? Now, the electronic component can store, can carry, can resist, can stir up, and can also act as a switch, can also act as a storage device. It can process. We are going to see it one by one. Before going into that, let us see the basic laws that we have already learned in the 12th standard. And really, do we know that practical implication or something like that? And I'm going to explain in a very short and in very quick manner how these laws are very important for all engineering branches, and specifically for EEE, ECE, and computer science. These laws are very important, and mostly the mechanical branch also will be using these laws. So first, if you consider the Coulomb's law, how this Coulomb's law is very useful for me. Now let's make a wind of this. So we'll go into the next template of the things. Just a second, we'll make a thing. If you consider the next laws or the next things, we'll just move on into the first principles of laws. The first principles of law says that the first one is it's your Coulomb law, right? So in case of a Coulomb law, when you consider, what they are saying is the force of attraction or repulsion is directly proportional to the, right, the charges that are separated by the distance, and inversely proportional to the distance between them, square of the distance between them. So why we are talking about this, right? Force, right? This force only we are calling it to be, when this force is turning to be an electrical force, then this force is turning as an electrical force, then I call that to be a voltage. I call that to be a voltage. So this is very important from the Coulomb's law only, and that is which is proportional to the charges, we define the term called as a voltage. So only we will measure the voltage is equal to joules per coulomb. And also the current is also related with this law, right? And if you say current I is equal to ampere per coulomb. So here that is very important. And sometimes if you remove this proportionality constant, we'll have a proportionality constant, Coulomb constant K. So this loss gives me a very good idea about how I'm getting a force. Whenever there is a potential difference, a charge difference, you are having a voltage. Okay. Now we'll move on into the next law and then we'll come back. The next, due to this, how to say is, due to this Coulomb's law of the voltage, there in 1799, Alessandro Volta devised a device called as a battery. Nowadays, starting from the light, starting from our laptop, and starting from our, and when you're talking about your mobile, you're talking about your tab or your gaming devices, for everything you require a battery. Without the Coulomb's law, it is not that much possible. So when you're coming with the battery, next, the magnetic field. This is very important. Whenever my current, that is I, is varying, that is changing, the magnetic field also will change. Or inversely, I can say that the change in the magnetic field will produce the current. The change in the magnetic field will produce the current. That was given by the Austin. Now, when I get the current as well as according to the Coulombs, when I'm getting a voltage, this Ohm's law can be defined very easily. which is very, very important law in an electronics for analysis of circuit, that is V is equal to IR. Using all this principle, they found out that is the current and voltage can be generated. They found out a device called as a generator. Then now whenever the Coulomb's law is there, one thing I have to remember, this voltage will be almost the voltage along the transmission line in free space. It will be called as an electric field, and the current will be exactly somewhat proportional to the magnetic field. So using these concepts, Maxwell, we can call this Maxwell and Hertz to be the father of communication, because they found out what is an electromagnetic theory and electromagnetic radiation. If there is no electromagnetic theory of light, that is formulated laws, you will be learning that in EMF, electromagnetic field subjects, and few other subjects will be concentrating this electromagnetic theory. This is very, very important in communication, that is Maxwell law. Next, if you come across electromagnetic radiation, now you use in all devices, for example, car, mobile, everywhere you are using the antenna. Without this electromagnetic radiation, do you imagine about the antenna? No, you cannot imagine about an antenna, because electromagnetic radiation is the base of an antenna. Antenna will be radiating which wave? Means electromagnetic wave. EM wave will be radiated. Okay, now the very talkable event in Twitter, in all other web pages, that is Tesla coil, right? This coil, initially it is used in all the radio and television. Now in the electric car and vehicle, we are going to use this principle. Now he is being talked much. Now for analyzing all these devices, laws and devices, and to mathematically formulate or to theoretically calculate my current and voltage value, we studied a Kirchhoff law. Now I hope so you have an idea why I have learned the Coulomb's law, why I have been learning the magnetic field, that is Ampere circuital law or Ohm's law, or I learned about the Maxwell's and the Hertz experimentation. Okay, so these are all the evolutions of the basic laws. Next, before going into the evolution of an electronics, electronics, let me ask you some questions. How many of you are able to understand? I don't know. Let me give you the questions, and I don't know how many of them are present over here, Ishrat. Can I note it down, or it is feasible? Okay, fine. Anyhow, a simple question. Can you able to understand now what is engineering, what is electronics, and what is semiconductor, and what are all its bases? If S, put S over here. I want you to post an S over here so that it will be okay. Anyone is available? You can put a S. Okay, fine. I think so. It is understandable to you now. Okay, fine. Thank you, Kavipriya and Ishrat. And next, when we are going to see over here is, listen here, the evolution of an, when we are coming for the thing, that is evolution of an electronics. First, the evolution of an electronics have started with the vacuum tubes. It is started with what? Vacuum tubes, which is founded in the year between 1886 to 1997. Walter Scotty, who lived in this period, he found that is this electronics, these are all said to be, these are all used to in the computing. It is used in computing. All these are called to be computing devices. And then these vacuum tubes are very huge in size, and it occupies a single huge room. Suppose if I want to do a simple calculation also. So once I said, as I have discussed about the semiconductor technology, once we have studied about the semiconductor technology, the first transistor was devised. The thing is, the first transistor was devised. So the first transistor was devised in Bell Labs, right? With the invention of the semiconductor technology, we get into the first transistor in the year 1947. Next, in 1959, with a gap between 1947 and 59, the Jackson Clark Helby founded an integrated circuit at Texas Instruments, right? Integrated circuit. What is an integrated circuit? Building number of transistors, right? Building n transistors, that is number of, now it is crossing million and trillion number of transistors in a single chip. In a single chip, we call it to be a integrated circuit, and for that the base is the transistor. Next is the invention in 1957 of Fairchild semiconductor device, which is also paved a way for the integrated circuit. And now, as I said, I'll give you a flow over here. Listen carefully how it comes. First is your vacuum tube. From the vacuum tube to the development, we got a semiconductor technology where initially germanium is used, then the silicon. From this, the devices developed are PN devices, that is diode, then the transistor. From the transistor, actually the gates are developed, right? AND gate, OR gate, which we have learned in the 12th standard, and others would have been very clear about that. And from the gates, we have devised a microprocessor, right? The first microprocessor is 4004 microprocessor. Now we are using that as, initially it was a Motorola. Now we are using all the versions of an Intel. Now we are using all the versions of an Intel. That is called as an evolution of an electronics. I hope I've given you some justification. Now, without the laws which we have learned previously, it is very difficult to analyze all these devices. These are called as an evolution of electronics. Next, this is just a photography. I want to show you how the first electronics, these three people, Bardeen Shockley and Brattain at Bell Laboratory, invented the bipolar transistors, right? So it around $4 trillion, roughly 50 years later, electronics count for 10% of the world GDP. So transistors plays a major role even in FM or AM, whatever we consider. In each and every component we have a transistor. So this is just a pictorial representation. Now, as an engineering student, I want you to know that, right? How we have gone with the flow, just we'll revise the flow, right? Who is an engineer, right? And what is the role of an engineer, how an engineer should be. And third thing, what we came across is the role of an engineer, branch of engineering, how they are dependent with each other. Next, across with the branch of an engineering, next we have seen the laws developed, all right? And before that, we have seen about the evolution. We have seen the evolution. Next, the laws. You know, what are the laws, starting from the Coulomb's law to Kirchhoff's laws, and how these laws and the different devices have been contributed from the vacuum tube to the processor. Everything is okay. Now, this is the flow I have taken you till now. Now, what I'm coming to say is, students many times think that I'm going to concentrate on a particular thing and I'm going to leave certain things. Many people are allergic towards mathematics, all right? And some people are allergic towards chemistry. And some people are allergic towards physics derivation. And my dear students, one thing I want to say to you, everyone, and to each and every people who are present over here, everything is fun. Without the chemistry, I don't have a called as a semiconductor devices. I cannot learn about the silicon or germanium. If I don't have silicon and germanium, then there is no concept of the transistor. If there is no transistor, then there is no devices, any computing devices, no computing devices. All right, and physics, and whatever laws we have learned which comes under your physics, coulomb's, ohm's law, and everything, and the experimentation, and whatever hertz apparatus, this we have learned in the, that is the unit number 1, chapter number 1 in the 12th standard, the hertz experiment. That will be an important question, so we'll be learning it. But here he only proved that there is an electromagnetic, right, electromagnetic concept, and the frequency concepts, everything he has been proving. So without this physics, now if I want to analyze this chemistry or physics and whatever might be the branches, not only pertaining to ECE, even if it is a computer science, even if you're doing a programming, even if it is an artificial intelligence, whatever might be the things, starting from the number system, without the number system nothing is feasible. So an engineer at least should know 30% of chemistry, right? 30, or I can say that 40% of chemistry is enough. Physics, if you consider, really we need to know at least 70 to 80. Mathematics almost 100%. Where an IIT student, and we are getting deferred, most of the students in IIT or in abroad, Massachusetts Institute of Technology, or wherever might be, why we can't become that people? We can become that people, right? We can assure that we will be there when we are thorough with all these things, when we follow all these fundamental things, chemistry, physics, and mathematics law. Now I'm going to show you how the max is fun for you, right? From a simple pi, that is pi, you know that it's a 180-degree. From that simple thing, I'm going to show you a video how it is very a funny material. That is how we generate a sine wave from that. We'll see to that video for just 3 minutes. Yes. Now we got the thing, a very important thing. Now I'll show you in this, I'll sketch and show you how this has been given an importance. Now listen here. You started with a pi. Actually, pi, that means your 180 degree. And when it becomes a 2 pi, it is 360 degree. And when we are dividing this 180 degree, right, into a half part of it in a radian, you will get a triangle. And once, if I'm rotating the triangle, once again I'll get a circle. From that I can find out the circumference and your diameter and your radius. When I'm able to divide all these things into for example, when I'm going to divide this into a quadrant, I can find out the sine and the cos. When I'm having the wave sine, which is the inverse is your cos, when I'm having this wave, obviously we'll get an idea about the frequency and the time. These are all the very important thing. And this value, that is your magnitude, that is amplitude. Why I'm saying all these things is a simple understanding, a simple thing is enough. A simple understanding is enough, right, to get into the mathematics. It is not that tough as you're thinking. It is very interesting and it is very fun. There are many videos in the YouTube also. Just try into the business thinker and you will get many things. Now, we are going to see that this electronic components are being divided into active component and a passive component, right? What are active component means? The device in nature can control the flow of electron. Here they are given as an electricity, but actually it means here it can control the flow of electron without the aid of any external device. You don't require any external device to make this to operate. In ideal condition, this can operate. So we call it to be an active component. புரியுதா சொல்றது? Active component அப்படின்னு சொல்றது, it can control. Okay, it can itself control. So what are the examples of an active component? Transistor, MOSFET, metal oxide, semiconductor, field effect transistor. Next one we have seen as an IC. I told now that is an op-amp, that is an amplifier. Then logic gates. These are all called as an active components. An electronic student should know what is an active component. Tomorrow I'm going to brush up each and everything, that is how these components are all used in design. Now listen here. The next is your passive component. Passive component in the sense is it cannot control, it doesn't have the ability to control the electric current. That is, electron cannot be controlled by the passive electronic component. For example, resistor, it can be connected with the active component to work, and it can be connected with the capacitor or inductor, or the sensor can be connected with the active component to have its work, to do its work. So these are called as these are the major difference between the active component and the passive components. Okay, and next, these sensors. If you consider a sensor, listen over here, this is another very important device. Why I'm specifically talking about the sensor is, tomorrow I'm going to talk about the basic two things. One is communication, and second thing, with the help of how electronics plus communication leads to, right, an internet of things, right, along with some softwares. This we are going to discuss tomorrow. So the very important electronic component in an internet of things, today we are talking very much about this internet of things, and it's booming fast. In that, the very important component is a sensor, right? What is a sensor? It is also a device, right, which can produce an output signal proportional to the, right, the physical phenomenon. What is that physical phenomenon? When obviously we know that according to the Ohm's law, V is equal to IR. So I will be equal to V divided by R. Okay, from this. So if the resistance of the material is changing due to the environment, see here, detect events or changes in its environment. If this resistance is changing, obviously the current will change. If the resistance is changing, voltage will change. That only, that is the output signal is changing. So when this output signals are going to change, this information will be given to an another electronics or a computer processor, right? For example, I'm sensing in a medical devices, if you consider thermometer, if you consider it is a sensor, right? And in daily uses, what are the daily uses? In fitness equipment, you have sensors to measure your heartbeat, to measure the speed of walk. Even there are devices now, how much time you sleep, your BP level, your sugar level, everything can be measured by the different, there are different kinds of sensors. Here just I've given a pictorial representation. You have a gas sensor, you have an IR sensor, you have many other different kinds of a sensor in medical as well as in the commercial product. You are having a different kinds of a sensor. So these are the things that you have to know as a basic. Next, evolution of an electronics, already I have told you, but devices, in respective with the devices, first they have used from the small to the large vacuum tubes, then they have come across the discrete transistors, right? In transistor there are different kinds of transistors. Now we come across the CMOS. Everywhere in our system we are using a CMOS. Then we are using a small scale integration and medium scale integration, that is depending upon the size of the transistors and the number of transistors we are using, and very large scale integration also. Here more number of million number of transistors will be devised, that is 10 power 6 or something like that. Here it will be ranging from 10 power 3 to 10 power 5. So that number of transistors will be used in the SSI and MSI, and VLSI it is 10 power 6, more than that. So these are the evolution of the electronic devices. Now when this VLSI is ready, now we have a processor. Now we are going to see about the evolution of the processors. We'll see a short video how the processors have been developed. So now you have seen. Now, my dear students, I can't be covering each and everything. I can't be explaining each and every concept and process. Now, just I've given you a vision that what is electronics and how the laws are being used, and then what are all the evolution, how the electronics are being developed, the semiconductor technology, how it paved the way for transistors, diodes, and from that how a processor is being developed. Everything I have told now. Now, where I'm using this, what is the where all I'm using this electronics, including home appliances. If you take over here in your refrigerator, microwave oven, television, air condition, in cameras, wherever you go, right, in appliances, when you're going to construct a smart home, everywhere you require an electronics, my dear students. And so you have a very good scope for if you learn an ECE branch. Next, in medical field, I'll come one by one, which are very important in our day-to-day life. Once after home, nowadays mostly we are visiting the hospitals, your CT missions, your MRI missions, your electronic microscopes, everywhere you go, right, without the electronics there are no medical devices. Your simple devices will take ECG. If you want to measure a pulse, BP, everything you require a sensor. That are all an electronic devices. Without that, so a student can go in a medical field after EC branch, after you are learning. If you're going to do an MS or something in abroad, you can do it in medical field. You can design some kind of devices that is in a computer or something like that. You can go for that field also. In all space applications, if you considered, right, electronics plays a major role in designing rockets and robots, all these things, right? All many kind of sensor are placed in this, what to say is, in spaces. Next is this, just I've given as an example, but in all transportation, including car, train, bus, airplane, jet, and whatever might be, you are using electronics. Automation, wherever we require an automation, the electronics plays a role. So everything what we live, what we breathe now, with the electronics. And nowadays, you know very well, a student or whomever might be, in corona period it was very well useful that our mobile, if I don't have a processor, it's over, right? If there won't be a, I would not have been a communication. Tomorrow I'll say that how equally the communication is important. Without this electronics and without the communication, you don't have an IoT devices. I hope so. I have given some justification. So lastly, I want to say you a quote. Walk like a king or a queen before being crowned as king or queen. Before you want to become an engineer, feel like and be proud like an engineer, so that one day the world will look you as an great engineers, and specifically in electronics and communication engineering. I wish all the best, and I thank the SA Engineering College for giving me this wonderful opportunity. Thank you, one and all who are present here. Thank you.
I would maintain that thanks are the highest form of thought, and that gratitude is happiness doubled by wonder. Gilbert K. Chesterton. Thank you, sir, for your outstanding discussion. We have now reached the end of this session, and this is the time to extend our gratitude for the successful completion of today's event, Evolution and Advances in Electronics and Communication Technology. Gratitude is like a magnet. The more grateful you are, the more you will receive. I deem it my privilege in proposing the vote of thanks. At the outset, I would like to extend my sincere gratitude to the management for providing an opportunity and extending full support to organize such an event. I would like to thank our principal sir, Dr. S. Ramachandran, for being a source of motivation and guiding us to conduct such events. I would like to thank our most eminent speaker, Dr. Benjamin Joseph, for spending his time with us and enlightening the stay with his knowledge. Profound thanks to the event organizing committee for playing a pivotal role in organizing and ensuring the smooth conduction of this event. I also thank all the participants for accepting our invitation and extending full support. So, dear participants, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificates. I once again repeat, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificate. So, I thank you all.